Alrighty, welcome to Algebra 1B. This is the first video in a series of many by yours truly, Mr. Pog. So today what we're going to do is we're going to start our unit on polynomials. So you might be noticing, like, what the heck? This is unit 4. We haven't done the first 3. That's okay. What we're going to do is we're going to start off here because I feel like it's probably the one that's best for us to do first online. And hopefully if we get back to school, we'll be able to switch into other things and all that. So first up on the docket is classifying polynomials. So you might be asking yourself, what the higgity heck is a polynomial? And so before we talk about what a polynomial is, we got to talk about what a term is. All right, so a term, a term could just be a number like 7. It could be a variable like x, or a product of a little bit of each. So a product of numbers and variables. Right? So you might have 7x or 7x, right? And that x could have an exponent on it, right? You could have like x squared, you could have y to the third, you could have, the letter r to the 740th power, right? Nobody really wants that, but you could have it. So polynomial is what we have when we have terms combined by operators. Right, so don't forget that operators are like the things that we do, right? So in general terms, right, the operators are adding, subtracting, multiplying, and dividing. Right, well, we're specifically focusing on polynomials are plus and minus. Right, so if you have pieces that are being multiplied together, right, that's not technically a polynomial in that state. We can change it into something that's a polynomial in some ways, right? We'll take a little bit of a look at that later on in this unit. But for right now, we're just focused on, when we're adding or subtracting these big chunky pieces we call terms. We've also got a couple different names that we might call these things. So, they are, like all of these things that we're going to talk about down here are all different types of polynomials, right? But we have specific names for them. It's like you could have breeds of dogs, and it's like, oh yeah, they're all dogs, but like this one is a German Shepherd, and this one's a Border Collie, and this one's a teeny tiny, whatever they call those ones, right? So we got these different like specific names. So the first one is a monomial, right? And all that means is that it is a polynomial with a single term, right? Just one, right? Mono is the prefix meaning one. If you're into audio stuff, mono versus stereo, mono just means it's coming out of one speaker, right? So mono, or monomial, means that you just have a single term. So it's just like, if we had a little example, I was talking about 7x, right? Let's call 7x squared, that's a monomial. If we have a binomial, right, it's got two terms, right? And when you're talking about a binomial, right, you'd have, our first thing, the 7x squared, and then what we would do is we would either add or subtract some other thing from it. So let's say minus 3y to the fourth, right? That would be a binomial, right? It's got these two different chunks that are broken up by that minus sign. Third, we've got a trinomial, right? So tri means 3. You think about it like a triangle or a tripod for a camera, right? It just means that it has 3 terms, right? And why let a good example go to waste, right? We'll take our binomial, and all we got to do is just add on another term, right? So just add it on 1, right? Don't forget that like numbers count as terms. It doesn't need to have variables. And even if I added a variable onto it, I could have 1z. That z doesn't necessarily need an exponent on it, right? That's fine. So monomial, binomial, trinomial, they go up in that order. So what we're trying to see is like, all right, is this thing a polynomial? If it is, we want to tell whether it's a monomial, binomial, or trinomial. Right, so it looks like a polynomial, right? I've got these two different chunks, right? I've got this 4y, and I've got this 5xz, and then just separating them in the middle is just a minus sign, right? So that is a polynomial, right? And if we're trying to figure out whether it's a monomial, binomial, or trinomial, all I'm doing is I'm taking a look at how many different chunks I have. So if I've got 4y, that's one chunk, it's one term, and 5xz is another one. So if I've got 2, that is a binomial. Same kind of deal for these other ones, right? We'll kind of go through these. So this just has one chunk, right? It's negative 6y squareds. There's nothing that's being added or subtracted to it, it's just its own thing. But, it is still a polynomial. And in this case, it is a monomial, right? Because it's just one chunk, right? We don't have two different pieces that are being added or subtracted. It's all just together. All right. Third up, we've got another one here. Oh, gross. Negative exponents. Blech. So don't worry about those quite yet. We are going to get to those. Normally, if we were doing things in school and everything was in order, we'd talk about negative exponents earlier. So here it kind of does mess things up a little bit. If you have something with a negative exponent, again, something we're going to get into in the future is that it actually kind of has some weird division-y thing going on. So here, we're going to say no, this isn't a polynomial. And it's no because of the negative exponent. All right, so that negative exponent unfortunately messes everything up for us, right? We cannot have this little negative 3 on top of that x. So them's the breaks. Nothing we can do about it. All right, it's not going to come up all that much, so don't worry about it too much, but it is something to be careful of. This third one here. All right, no negative exponents, so things are looking pretty all right. I've got that chunk plus this chunk in pink plus this chunk in blue. Seems like I've just got some chunks that are being added and subtracted. So yeah, that's a polynomial. And in this case, that is a trinomial, right? Because I've got these 3 different pieces that are all kind of being added and subtracted from each other. All right, sweet. We've also got to talk about something called the degree of a monomial. Right, so these monomials and polynomials and everything else are pretty smart. They've got multiple degrees. Haha, but wow, actually, since I'm doing these from home, I should queue up a little rim shot with the symbol and everything. Maybe I'll do that, we'll see. So we've got the degree of a monomial. All right, so we're going to first classify them as monomial, binomial, or trinomial, or sometimes just polynomial. Right, but then after that, we can figure out the degree depending on what it is. So monomials have their own special rule for it. Right, so the degree of a monomial is just the sum, right? So you're just adding together. It's the sum of the exponents of the variables. Oops, and my little recording thing is on top of it. Sum of the exponents of the variables. All right, so if I had something like, let me kind of scooch off to the side here. If I had 3x squared y to the third, right, that has a degree of 5 because I'm taking a look at the 2 above the x and the 3 above the y, and I'm adding them together. Right, so that is a degree of 5 for that monomial. Right, if I switch things up a little bit, right, say I just had 3x. Right, so don't forget that, when you have just a single variable, right, it does have an exponent on it. Oops. That exponent just happens to be 1. So in that case, what we would have is we would have a degree of 1 on this monomial. Right, but again, if I had 3x, y, z, right, each one of those has a tiny little 1 on it. So that degree is actually 3 there. Right, so we're taking all the exponents from each one of the variables, adding them all up, and that is the degree of our monomial. Right, so if I had 2, 3, and 4, 2 plus 3 plus 4 is 9. The degree of that is 9. When we get into polynomials, things get a little trickier. Right? So the degree of a polynomial is going to be the highest degree of any monomial term. Right? So if you think about it, right, we were talking about different types of polynomials on this last page. I'm going to swing back a little bit. Right? So anytime I highlighted one of these and we were naming them by how many terms I had, right, this one for number 2 was a monomial, right? It was just a single term. So really, what I'm doing on these other ones, right, say I'm taking a look at number 3 then, right? This 7x to the negative third, right? Actually, let's not use that one. That was not a great example. Say we talked about this 4th example here. If we had 6x to the third, that in itself is a monomial, right? 4x is a monomial, and 3 is a monomial. right? So when we've got this trinomial all put together, it's really made up of 3 different monomials, right? Each individual tiny piece. So that's what we're kind of getting at here, right? Is that the degree of a polynomial overall is you're going to take a look at it. You're going to figure out where is the highest degreed monomial piece of it, and then we're going to take that as the degree of the whole thing. All right, so we'll talk about that a little bit more. We'll do some examples, but first we got to figure out how we're actually going to name them based on the degree. So classifying by a degree. If you have a degree of 1, what we do is we call that linear. All right, so something you guys have all taken a look at in Algebra 1A are things like, oh, y equals mx plus b. You notice that x it's not y equals mx to the 4th plus b, right? It's just a single power on top of that x, right? It's just a degree of 1, so it makes a straight line. All right, when we've got a degree of 2, what we do is we call it quadratic. And quadratics are something that you guys will be taking a look at sometime way into the future during Algebra 2. All right, we're not going to graph them or doing much of anything other than just naming them. All right, if you've got a degree of 3, what we're going to do is we're going to call it cubic, right? Because we're working in the 3rd dimension. And if you got 3 dimensions, you can make a cube, and you can make dice. You can play a little game, do whatever. If you got a degree of 4, what we do is we would call it quartic, right? If you think quart, like quarter, it means 4. And if you've got 5, you've got a quintic, right? And quint, like a quintet. It's like a way of having a group of 5 things, right? So a degree of 5 is quintic. And then for anything 6 or greater, we don't really have a name for it. So we put not applicable, or if you like to say it this way instead, nah. Right? This is nah. We don't have a specific name for it. What we do with this one though is that we say it's of degree whatever it is, right? Or you might say it's a blank degree polynomial, right? You might say that it's like a 7th degree, or it's a polynomial of degree 7. And so it kind of, there's a couple different ways you could say that. Either one is fine, right? But we don't really have a specific name like the other ones. Cool, so let's actually find some degrees for these things. All right, so for the monomials, we took a look at a couple examples. They weren't really all that bad, right? All I'm doing for this one here on 5A is I'm just taking a look at all those variables. Right? I'm taking a look and saying like, all right, this x has a squared, this y has a third, add them together and your degree is 5. Done. That's it. All right, so when you have a monomial, all you're doing is you're just adding up all the exponents of all the variables, right? If this 3 had a squared on it, we wouldn't count that because 3 is not a variable. We know what 3 is. Right? So just the stuff on the variables. Over here on this one, right? Remember how I was talking up at the top of this page that there are little hidden ones whenever you don't already have an exponent there. So in this case, I'm taking this 1, this 5, and this 1. 1 plus 5 plus 1 is 7. Cool, so our degree there is 7. And that's it. Right? So monomials, not too bad. For polynomials, right, again, these are the ones where it gets a little bit trickier. Right? What we need to do is we need to take a look at each term, right? So let's start off with that. Let's go through this first term here, right? 2x to the third. 2x to the third, the only exponent that it has is 3. So this has a degree of 3. Right? This piece in the middle here, this negative 5x to the 5th y. Taking a look at the exponents of those variables, right? Don't forget that y is a 1. And altogether, that has a degree of 6. And then last but not least, we've got 7. So 7, like we should probably definitely talk about this, doesn't have any exponents. It doesn't even have any variables to have the exponents. Right? So there aren't any exponents on the variables because there aren't any variables. So if you don't have anything, you do is you just say that it has a degree of 0. Right? Cool. So then what we do when we're trying to find the degree of the polynomial is we take the largest degree of any single term. Right? So then we would say that our degree is 6. Right? If one of those, if either the red one or the orange one had a higher degree, to the term, we would choose that one instead. Right. So what we're going to do on here, same kind of deal. I've got these invisible ones that I can kind of fill in on those, but then we're just going to take it one term at a time. So over here, that term has a degree of 2. This second one here is 1 plus 2, which is 3. Let's change that 1 to be blue so it matches. I'm looking at this third term here. We got a 2 plus another 2 gives me a degree of 4. And then this one on the end, right? Doesn't have any variables whatsoever. So it doesn't have any exponents on any variables. So it's got a degree of 0. Alright, cool. So again, what we're doing is we're taking the largest of these, right, which in this case is 4. So our degree is 4. That's all there is to it, right? So when we're doing polynomials, like doing a whole kit and caboodle of them, what we're doing is we're doing the same thing we did for monomials, right? Just add up the individual pieces, but then we got to do this chunk where we're going to find the biggest one and take that as our overall degree, right? That's all that really means. We're almost there, right? We've got the standard form of a polynomial, and then we're done, right? So the standard form is basically telling me about when I'm writing terms in a polynomial. Starting with the greatest power. The greatest power. Sounds like something out of the Avengers. Starting with the greatest power and decreasing. Right, so basically what that means is that we're going to be taking a look for, we're going to write it in standard form with regards to some variable, right? So depending on whether you have just x's or maybe you have some x's and y's floating around, you're going to choose a variable. You're going to write it for standard form in that variable. And all that means is that I'm going to take a look for like what chunk has the highest power, write that one first, and then write the other ones afterwards. So a couple different ways you could do this, right? One way that I've seen people do it in the past is that they like to chunk out the terms first. Right? And actually, let me do this a little bit differently, so it's a way you guys can do it without highlighters. I'm going to grab the terms along with the symbols that come in front of them. All right, so I've got 3x squared, I've got plus 4x to the 5th, and I've got minus 7x. Right, so what I need to do is I'm going to find out which one has the highest power. Right, so it looks like 4x to the 5th, that's got the biggest. So what I'm going to do is I'm going to put that one out in front, 4x to the 5th, and then I'm going to take a look for the next biggest one. All right, so x squared would come next, right? It has a power of 2. All right, so sometimes a little bit of a tricky thing here is to remember that that 3x squared that's hanging out in the very front is a positive 3x squared, right? There's no negative in front of it. It's just a regular positive 3. So when I'm adding this onto here, I'm going to say plus 3x squared. Right? After that, I need to go on to the part that has the smallest power. Right? In this case, it's negative 7x. So I'm going to put minus 7x. Cool, that's it. Right? So if I'm trying to write something in standard form, it's not really too difficult. I'm just looking for what's got the biggest exponent on it, go down from there. Last one. Oh boy. And so again, what I'm going to do is I'm going to take each term. I've got this x. I've got this plus 5x to the 3rd, this minus 2x squared, this minus 7x to the 6th, and this plus 10. Phew, 5 different things. Oh my god, it's going to be so awful. Psych, not going to be that bad. I'm going to take a look for which one's the biggest. It's got the biggest power on it, which looks like minus 7x to the 6th. So minus 7x to the 6th comes up first. And then taking a look for the next biggest, which looks like it's those x to the 3rds. So plus 5x to the 3rd. Taking a look after that. Looks like I've got those minus 2x squareds for the orange there. So, whoops. We got minus 2x squared. After that, I'm taking a look, and then all I've got left are the red and the purple. Right? I've got this x and I've got this 10. So again, remember that the x has a first power on it. And technically, that's more than the no x's that the 10 has. Right? So we're going to put plus x, and then that 10 is going to hang on to the end of there. And that is it. What I would suggest is to check Google Classroom to figure out what else you got to do for this, and I'm out.